Good morning and welcome to Chapter 8, Part 2. So today we're going to talk about a one-sample t-test, okay, where our sample data is a sample mean, and we're going to compare that sample mean to a hypothesized population value or test value. So here's the data we're working with today. We're working with modern racism scale data. So what is the modern racism scale? Well, it's a measure of explicit prejudice. So some of the items that are included on this scale include, over the past few years, the government and news media have shown more respect to blacks than they deserve. Discrimination against blacks is no longer a problem in the United States. Blacks should not push themselves where they're not wanted. Okay, so those are three items that are on the scale. So people could either disagree strongly with those items, right, and therefore they'd be scoring lower in explicit prejudice, or they could agree strongly with those items, and therefore they would score higher in explicit prejudice. So there are two types of prejudice. There's explicit, where people explicitly say things that are prejudice, and then there's implicit prejudice, which is based on socialization in our culture, and it's this prejudice that's kind of ingrained, that's not necessarily explicit. So everyone has implicit prejudice, whether it has to do with race, ethnicity, religion, social status, hobbies. Everyone has some sort of implicit prejudice just based on how they were socialized. But they wouldn't understand that they had this implicit prejudice because it's implicit. Whereas explicit prejudice, people understand they have a prejudice and they talk about it, just like those items reveal. So what can we do with these data? Well, if you think about it, okay, so the lowest possible explicit prejudice or modern racism scale score would be a 1, right? So if if a participant scores a 1 in all the questions, you take an average, they got a 1. The highest possible score is a 5. So if a participant scores 5 on all the items, you take an average, they get a 5. So there's a middle point. The middle point or midpoint of the scale is 3. 3 is like ambivalence. It's neither agree nor disagree. So what we're going to do is we're going to use 3 as our test value. Okay? And what we're trying to see is, on average, do people score lower in explicit prejudice or higher in explicit prejudice as compared to the midpoint, which is ambivalence? So that'll be more clear as we look at our null and alternative hypotheses. And really my motivation for using this as my example is in grad school, I worked with prejudice data, both explicit and implicit prejudice. And what I was finding when I was looking at these explicit prejudice data is, on average, people aren't prejudiced explicitly. And of course, these are California samples, so it's probably different from other areas across the country. So based on those data, one can make the argument that prejudice is gone, which clearly isn't the case. It's just explicit prejudice, isn't something that the culture values, but implicit prejudice is around, like I said, due to socialization. So that's one thing I was finding. I presented at a conference about it. It was interesting just to think about. It was a great thought experiment. So let's go ahead and begin, and let's do the one sample t-test. Okay, and remember, the logic that we used last time is going to be the same as the logic we're going to use today, which is going to be the same as the logic that we're going to use for the rest of the class, which is a great thing. So through this repetition, I feel like you're really going to understand it, and it's just going to be, it's going to be great. Okay, so the null hypothesis is mu equals 3. The population mean modern racism scale score may be 3. Okay, so if it's 3, that means on average in the population, people are scoring in the middle of the scale. Okay, the middle seems to represent ambivalence, like I was saying. It's like, I don't agree or disagree. Okay, now let's look at the alternative hypothesis. Let me get a new blue pen. Okay, the alternative hypothesis is mu does not equal 3, or, and to say the same thing, mu minus 3 equals 0. Sorry, does not equal 0. And then this one could also read, sorry, I forgot to mention that. Mu minus 3 equals 0. So mu equals 3. Okay, but if mu equals 3, then mu minus 3 equals 0, right? 3 minus 3 is 0. So it's the same thing over here. Okay, great. So this is our null and alternative hypothesis. One more thing about the alternative hypothesis, if mu does not equal 3, we can figure out, where it is. Is it significantly lower than 3 or significantly higher than 3? So if it's significantly higher than 3, that's telling us that on average in the population, people exhibit higher explicit prejudice, or they are explicitly prejudiced. If it's lower than 3, it's saying on average in the population, explicit prejudice is either low or doesn't really exist. Okay, so step 2, we need to select our alpha level. Okay, and for the purposes of this class, our alpha is always going to be 0.05. We have to find our degrees of freedom. The equation for degrees of freedom is going to be n minus 1. So n would be super easy in this case. How many participants do we have? Well, we have 10. 10 minus 1 is going to be 9. So once again, to find our T critical, we have to use our alpha and our degrees of freedom, which we just found. So our T critical is going to be T crit alpha 0.05, 9 degrees of freedom. Okay, so now again what we have to do is we have to go to our T distribution table on Canvas, and we have to use that table to find our T critical value. So let's go ahead and do that right now. Okay, so we have to find our T critical value. So once again, you need to go to Canvas, and once you go to Canvas, just go to Files, and you'll see a Tables folder, and in that Tables folder, you'll see the T distribution. So just go ahead and download that, and then you can go ahead and look at it. So we'll just open it right now. Okay, so just as before, our alpha level is 0.05, and we're always going to be doing a two-tailed t-test. Okay, so alpha 0.05, and we have 9 degrees of freedom. So it looks like our T critical value is going to be 2.262. So once again, that's alpha 0.05, two-tailed test, 9 degrees of freedom, and we have 2.262. Okay, welcome back. So we found our T critical value, and we found it to be 2.262. Okay, so once again, once we have this T critical value, we could draw our rejection region picture. So let's go ahead and do that. Remember the T critical, in this case, because we're doing a two-tailed test, that's our standard, alpha 0.05 two-tailed test, it's really going to be plus or minus. Oops. Okay, so we have our negative T critical, negative 2.262, our positive T critical, positive 2.262, and then if the T obtained that we're about to calculate falls in this rejection region, we're going to reject the null hypothesis, P is less than 0.05. If it falls in the middle, we're going to retain the null hypothesis, P is greater than 0.05. If it falls in this rejection region, we're going to reject the null hypothesis, P is less than 0.05. So I forgot to give you your givens for this problem. So you have to calculate the mean and the standard deviation for this distribution of modern racism scores. But I'm just going to give you those because we've already done that. We're moving on. So go ahead and write this down. The mean of this distribution is 1.715, and the standard deviation is going to be 0.49. Okay? So go ahead and write that down. I now need to erase it because it's, you know, taking up a lot of real estate on my board. Okay, so step 5, we're calculating the t obtained. So t is equal to the sample mean of our distribution minus our hypothesized population value, or our test value, which is 3, divided by the standard error of the mean. Okay? And this is further defined as standard deviation divided by the square root of n. Okay? So let's go ahead and find this first. So the standard deviation I said was 0.49, okay, divided by the square root of 10. Let me go ahead and grab my calculator so we can do this together. Okay, the square root of 10 is going to be 3.16, we'll just call it that. 0.49 divided by 3.16. It looks like we're getting 0.15 or 0.16. So let's go ahead and do that. We'll round up in this case to 0.16. In my notes it's 0.15, but Okay, so we have the denominator of the equation. Now we need to figure out the numerator. So t equals our sample mean, which is 1.715, minus 3, which is the hypothesized population value, or our test value, which we pick, and we determined it is 3. You can pick anything you want. Divided by 0.16. So as you can see, this equation is pretty nice. Not too difficult at all. Okay, 1.715 minus 3 is negative 1.285 divided by 0.16. You're going to get negative 8. So let me just check one thing. Okay, so because we divided by 0.16, we're getting negative 8. In my notes, I didn't round up. I used statistics rounding, okay, which has different rounding rules, which isn't really that important. So I divided by 0.15, so the notes say negative 8.56 instead of negative 8.03. It's fine. That's very minor. It's not going to make a huge difference. But since we divided by 0.16, let's make it negative 8.03. Okay, so our t obtained is going to be negative 8.03. Perfect, moving right along. So what we can now do, right, is we could stick this T obtained in our picture here and figure out, you know, if we're going to reject or retain the null hypothesis. So -8, it's going to be definitely over here in this rejection region. Okay, cool. So I'm going to go ahead and write the interpretation, then we'll be good to go. Okay, so I'm going to erase this portion of the board. Okay, remember from last time, we're going to use absolute value. Just so we don't have to deal with negative numbers. That just makes it a lot harder than it needs to be. Okay, so let's go over this first portion. So our T obtained of -8.03 is greater than our T critical 0.05, 9 degrees of freedom, equals -2.262. Therefore, our P is less than 0.05. Okay, so because of that, we're going to reject the null hypothesis. We know that because we're in the rejection region. P is less than 0.05. And we're going to restate the alternative hypothesis, right? Because we rejected the null. So this is the alternative hypothesis. And it's saying the population mean modern racism scale score is not equal to 3. But what direction is it in? Well, we find the direction by going back to our sample data and looking at our sample mean. So our sample mean was at 1.715, which is below 3. Specifically, the population mean modern racism scale score is significantly, so we could say significantly because we're rejecting the null hypothesis in p is less than 0.05. So specifically, the population mean modern racism scale score is significantly lower than the midpoint, which is 3, of the scale. Okay. So on average, people are disagreeing with the items in the modern racism scale, which is an indication that on average, people are not explicitly prejudiced. Okay, now I'm going to add some words explaining why we made the decision we made. Okay, so let's go ahead and finish the interpretation. So the probability of the sample data obtained, and our sample data, again, you can think of it as our sample mean or the sample mean difference. 1.715 minus 3 is negative 1.285, which was the numerator of our t obtained equation. Because of this small probability, it is concluded that the mean of the population from which the sample was drawn is probably not the mean specified by the null hypothesis. Well, again, let's break this down. Draw a picture. Okay, what is the proposed population value? Mu equals 3, right? The probability of the sample data obtained, so getting the sample mean of 1.715, if the null hypothesis is true, okay, the null hypothesis is true, mu equals 3, is less than 5%. So the probability of getting this sample mean if the population value is 3 is going to be less than 5%. Okay? If this sample mean was closer to mu, the probability could become greater than 5%. And therefore, we would have retained the null hypothesis instead of rejecting it. Okay, so because of this small probability, it is concluded that the mean of the population from which the sample was drawn is probably not the mean specified by the null hypothesis. Okay, so if this is true, okay, so if we live in a population where the population mean value for the modern racism scale is 3, okay, and then we sample from the population and we get 1.715, we're saying, well, to sample from the population and get a sample mean of 1.715 is extremely small. Therefore, we don't think that the population mean is 3. We think it's something else, okay? We think we sampled from a population, okay, where the population value is not 3. It's something different. It's something closer to this. So who knows? It might be, let me get a red pen. It might actually be mu equals 2 or mu equals 1. We'll never know, but we know based on probability that it's probably not 3. Okay. Sample mean did not occur by chance in a population where the population mean equals, oops, shouldn't say 0, it should say 3. And again, this has to do with sampling error, right? So if the population value is 3 and we sample from the population, we're likely to get sample means that are all around 3, but not 3. And this is due to sampling. This is due to sampling error. Okay. So we're saying that due to sampling error, if we sample from the population, we get sample means that are all around that hypothesized population value. We're saying that these differences, if you will, occurred by chance. But since ours is so different, we're saying, no, it didn't occur by chance. It must be telling us that the population value is not equal to 3. Okay, it's somewhere closer to that sample mean. Okay, so we found a significant difference. So now let's take it one step further. Okay, let's do a 95% confidence interval where we are able to more specifically estimate exactly what that population value is. So to do that, I'm going to erase this little example here. So we're doing our 95% confidence interval. This is step 8. We have our lower limit. Okay, so the only difference between our upper limit and our lower limit is our lower limit we're subtracting, our upper limit we're adding. Okay, so what's our sample mean? Our sample mean is going to be 1.715. Our T alpha was 2.262, and our standard error of the mean is going to be 0.15. So T alpha is our critical, so that came from us looking up our critical value. The 0.15 was the standard error that we found when we were calculating T obtained, and of course that's just our sample mean. So let me go ahead and grab my calculator. Let's do this together. So we have 2.262 multiplied by 0.15. Okay, so over here we have 0.3393. Okay, but you could round that to 0.34, so we could do that. So 1.715 minus 0.34, and we're getting a 1.375. So we just round that up to 1.38. So we could call our lower limit 1.38. Now let's do our upper limit. So it's going to be, it's going to be the same except for that minus 1.715 plus 2.262 multiplied by 0.15. Okay. 2.262 multiplied by 0.15. Again, this is going to be 0.34. So 0.34 plus 1.715, and we get 2.055 or 2.06. Okay, so we have our lower limit and our upper limit. So let me go ahead and write an interpretation. Here, let me. Okay, you see that? I'll have to erase what we just did. So lower limit 1.38, upper limit 2.06. So 95% confident that the population modern racism scale scores between a 1.38 and a 2.06. Okay, so that's definitely below that 3, right? 3 isn't included. Remember what the null hypothesis is saying. The null hypothesis is saying the population modern racism scale score may be equal to 3. Well, is 3 a possibility? No, 3 is not a possibility, so we reject the null hypothesis and interpret the alternative hypothesis just like we did. Okay. So there's another way of doing the confidence interval, where instead of just looking at the sample mean and the population value of 3, we can actually look at the difference between the two. Let me show it to you. It's doing the same thing. So you could do it like this. Lower limit, okay, sample mean, minus the hypothesized value, minus the t-critical multiplied by the standard error. Okay, so the sample mean we got is 1.715, right, minus 3, then minus that critical value, which is 2.262, multiplied by 0.15. Okay, so now let's go ahead and do this. Again, this is just an alternative method. You could pick either method, but it's just a different way of looking at it. If you remember when I gave you the null and alternative hypothesis, for example, for the null, I said mu equals 3 or mu minus 3 equals 0. Well, this is the mu minus 3 equals 0 interpretation. Okay, 2.262 multiplied by 0.15. Again, this is 0.34. So 1.715 minus 3 is going to be negative 1.285. We could just call it negative 1.29 minus a 0.34. So we're getting a negative 1.63. So in the notes it's a negative 1.62. The reason being, in the notes I don't round to 2 decimal places every time. I use infinite decimal places. Let's do the upper limit. So it's going to be the same thing except for adding here. So 1.715 plus 3 plus 2.262 multiplied by 0.15. Okay, let's do it again. Sorry, this should still be minus 3. Yeah, so once again, this is going to be 0.34, and I forgot what this one is, so let's do it again. 1.715 minus 3, and this is going to be plus 0.34. So it's going to be a negative 0.95. Okay, so there you have your lower limit and your upper limit in terms of looking at it as a difference. So let me interpret that for you. Okay, so we're 95% confident that the difference between the population mean modern racism scale score and the midpoint is between a negative 1.63 and a negative 0.95. I actually don't like this method as much because I don't think it's as straightforward, but here's what it's doing. So remember the null would be mu minus 3 equals 0, okay? And the alternative would be mu minus 3 does not equal 0. So the thing you have to ask yourself if you're doing it using this difference method is 0 a possibility? So because 0 isn't a possibility, you're going to reject the null hypothesis. So the actual population modern racism scale score is going to be below 3, right? Because it's negative. So you can use either method. I just wanted to give them both to you. Okay, so the last thing we're going to do, now that we found that there's a significant difference, we can calculate the effect size. Effect size is going to tell us how big the difference is. So remember, effect size, how big the difference is. Okay, here's our equation. D equals x bar, which is our sample mean, minus our hypothesized population value, or our stated value, which is 3, divided by the standard deviation. So our sample value is 1.715 minus 3, and our standard deviation is 0.49. So there you have it. And if you do that calculation, you're going to find that D is negative 2.62. Okay. Okay, so how do we think about D? So D has some cutoffs we have to pay attention to. So a D that's plus or minus 0.2 is going to be small. Plus or minus 0.5 is going to be medium. Plus or minus 0.8 is going to be large. Okay? So we got a D of negative 2.62, which is way above a negative 0.8, so it's going to be very large. So there's a very large difference between the population mean modern racism scale score, and the midpoint of the scale. Okay? So the difference is huge. Huge in which direction? Negative, which means it's below the 3. Okay? Okay, so take a look at that. Then I'm going to erase it so it doesn't distract us from the next thing we have to do. Okay. So, what if we retain the null hypothesis instead of rejecting the null hypothesis? Let's look at what it would look like. Well, your T obtained would have to be below this 2.262. So let's say you got a -1. Okay? Well, that wouldn't fall in the rejection region of your picture. It would fall in the middle, which is retain the null hypothesis. P is greater than 0.05. So P would be greater than 0.05. Therefore, you would have to retain the null hypothesis, and then you would restate the null hypothesis. Okay, so the population mean modern racism scale score may be equal to 3. Retain it as one among many hypotheses that these data support. Specifically, the population mean modern racism scale score. Actually, you would strike this entire statement, right? Because we're saying that it may be equal to 3. Though, I suppose, I'm going to slightly take that back. It depends on what your hypothesis is. So our hypothesis was that the population mean would be significantly less than 3, right? So if you had a population like that, then you could do this. Specifically, the population mean modern racism scale score, you could say is not significantly lower than the midpoint, right? So that's a good statement. That works out. Okay, the probability of the sample data obtained, if the null hypothesis is true, right? It's going to be greater than 5% because of this large probability. P is greater than 0.05. It is concluded that the mean of the population from which the sample was drawn is probably the mean specified by the null hypothesis. Sample mean did, so this would change to sample mean did occur by chance in a population where mu equals 3. Okay. Well, that's all I have for you today. So be sure to send me an email if you have any questions. You all have been doing a great job at that. So I love to answer questions. It's a good opportunity for me to interact with you and actually know that you're in my class. Let's go ahead and pray. Dear Heavenly Father, thank you so much for this new day, for giving us the opportunity to wake up, to appreciate this amazing creation that you've given us to enjoy. Thank you for giving us the wisdom, Lord, to turn to you and to ask you, Lord, here I am, no longer I, but you who lives within me. Lord, lead me to the mission that you have for me. Dear Heavenly Father, we love you and we praise you. In Jesus' name we pray, Amen. Have a nice day. Take care.